Yeah, so uh, let's start. So, welcome to my talk, How to Think Like a Hacker. So, this is how a hacker looks like if you didn't know, if you ask ChatGPT. Purely accurate. So, let's start with me and why you should listen to me. So, I work as a penetration tester for a company called Knowit. Um, I'm also a red teamer, meaning that I'm doing physical penetration tests where I actually break into buildings and install backdoors into systems where it's harder to find them, more or less. I have a Master of Science in Computer Security from Blekinge Tekniska Högskola. I started as a cloud background engineer, so at a cloud provider, I worked at their backend, just trying to fix everything that was broken, more or less. So I have worked a lot with networking trouble issues. I have 2 kids at home, so my spare time is like minimum at the moment. But in my spare times, I like to play board games and some role playing whenever I have the time for it. And as you can see in the picture, I'm always the most serious guy in the office, so take me seriously. So, why should we care about how a hacker thinks? And I just took some examples over the last few years. This clicker is not doing what it's supposed to do. But this is some examples on why we should care about how an hacker thinks. So there's a lot of hacking attacks happening everywhere all the time. And to be able to stop this and prevent your company from actually being a target for this, we need to start thinking how an hacker thinks to be able to stop it. And I did this talk for an automotive company, and they said, well, all of these are just pure IT attacks. So I just, okay, sure. But all of these ones are for cars. So just because you are in a smaller niche part of IT security, you're still a target for cyber attacks. And one thing I think is fun with just all the cars, there's one blue link vulnerability that allows thieves to remotely start cars. I think that's fun as a penetration tester. Someone was pretty happy when they found that, I guess. Some statistics for cybersecurity or hacking attacks in general. We can see that in 2023, we had a 72% increase in data breaches. So the data breaches are becoming more common, and I think that is because we're putting everything on internet today. Everything should be connected, and with a larger attack surfaces, more breaches will happen. That's just how it is. The average data breach costs around $5 million. That's on average. That's a lot of money for one single data breach. And just business email compromises accounted for about 3 billion losses in 2023. So there's a lot of money in the business as well. And that's usually what our adversaries are up for, or what they're after. So if you dive into an attack, we usually say that there are 5 things that are needed for a cyber attack to actually occur. So you need a motive, some resources, intent, opportunity, and vulnerability. If all of these combine, then you have a cyber attack. Motive is, it can be pretty much anything for a hacker. Curiosity is one big part. Everyone is just curious, can I do this? That can be a single or easy motive to fix or to have as an attacker. Resources, also pretty, can range from everything that a kid in his basement with a computer to a nation, more or less. So we have a large range of resources that can be used during an attack. Intent, usually good or bad. We have black hats and white hats, hacking for profit or hacking for the good cause or just being destructive. And the last 2 points, opportunity and the vulnerability, are the only ones that we as the defender actually can do something about. So if we are minimizing the opportunity for an attack to happen and make sure that our systems is up to date, the risk of a cyber attack will be smaller. So what we're going to do in this presentation is that we are diving down into a scenario where we take the role as an attacker. So our motive in this case is just we're curious how a website works and see if we can break it. The resources that we have is just this computer, nothing else. Our intent is that we would like to fix the things that we are finding because we are white hats. Opportunity and vulnerability we will see when we get there. And all attacks can be described during some methods. I'm using the kill chain. It can also it can also be I can't speak today. Meter attack is also a method of describing an attacker attack. Why I use the kill chain is because this is developed by Lockheed Martin, so it's developed for physical warfare in the beginning, but it works the same way in an IT. So we're going to deep dive in each of these steps just to see how it works and how it looks like when we do an attack on a system. And we need to start with reconnaissance phase just to bring a understanding on how what the targets are. The website that we're targeting is a demo website that I've built. I'm not a good programmer, which you will see. But one thing to keep in mind that all vulnerabilities that I will show here are findings that we have found during real penetration tests on real systems. So these are findings that we have found before. I just can't show you where they are found because of NDA. So let's continue, or let's start with the reconnaissance phase and see how that looks like. So the first thing that I do is we have our target. It's called Reptilian Daily, which is a news site for reptilians to get up with the news with everything that happens for all the reptilians in the world. So the first thing I start with is just scanning the server. So I want to see what ports are open in the server. So I just use a command called nmap. It's a free tool that is a port scanning. It does a TCP connection to each and every port, and then it just tries to enumerate what is behind it. And it takes a while, so we need to have a time lapse for it while we wait for it. So it usually, yeah, it's done. So the first thing that we have here is just a fingerprint of the service. So the nmap didn't recognize what exactly was on it, so it fingerprinted if we wanted to create our own mapping for it. And then we can see that we have some ports that are unknown. We have some TCP wraps on 30,000, a port 880, usually for HTTP proxies, things like that, legacy systems can be. And if we continue to scroll up, we will see that we have our web server, which is hosted on port 80 and 443. And we have an FTP server as well. So that's what we have from our first reconnaissance steps. So we know that it's a web server, it's running something else in the backend as well, or in the background as well, which we can't see from the website. So I'm just going to do the same scan again, just to have it in a little bit, a clearer format so it's easier to work with. So what did we find? I've already gone through some parts of it. We did an FTP, or it was an FTP. See if I can get this to work again. 18443 is just the web server. And then we have something that's listening on port 880. So this is usually some kind of proxy or something like that. It's responding with the HTTP at least. So we know it's some kind of web server. And usually when we find these kinds of ports, it's most likely a legacy system. and that has not been removed for some reason. And then we have ports 30,000 to 30,009. Anyone that has worked with FTP might recognize these as the callback ports for FTP. Otherwise, yeah, it can be unknown. And then we have something that is truly unknown. I have no idea what is running on my server. But yeah, so if anyone knows the virus that are listening on that port, let me know. So let's continue with our reconnaissance. So we know that we have some ports open. Our next step is try to find users. Because if we have users, we can probably log into the system. And on this website, if you go to each article, you can scroll down and you can see what's written about the article. And at the bottom, you can see something that looks like a username. And it's the same for all articles. If you scroll down on this page, we can see that we have Rizzo the Rat, we have Pinky, yeah, Pinky again, Rizzo. So there are some things that are repeatable on the website that looks like a user. So what we're gonna do is we're gonna grab a program called Hydra, and we're gonna try to log in with the user Pinky on the FTP server. So I'm using a word list here, and the word list contains passwords from previous data breaches. So these are passwords that are found in the wild a time ago. And then I will try every single password in that list to see if I can log into the server with the user Pinky. And after about a second, I see I can log in with the user Pinky with the password. So from this, we can deduct that the password policy of this web server is shit. So that's our first finding for a penetration tester, that we need to fix the password policy. Okay, so I used the program Hydra to do this. It's a password brute forcing tool. It's totally free. Everyone can download it and just run it. And it can be used to more or less whatever you want. FTP servers, web server, yeah, anything that you can port to it. It will just try to log in. And now that we have a username and password, we can log into the web server as well with the same username and password. So they are reusing the password in this case, which is also a finding as a penetration tester. Once we're logged in to the server, we are treated with an edit site here, meaning that every article that our user Pinky has written, we can edit. So if we were an attacker, we could deface the entire website here and just put nonsense. So I just try to update something. I can see that the message I see on the website is actually in the URL as well, which made me think, oh, I wonder if I can put whatever I want in the URL and get it to go into the website. So what I'm trying to do here is I'm trying to inject a templating language code. So something that a template language will actually calculate for me. So in this time, I use square brackets and just write 7 times 7, and I get the output 49. So I know that there's a calculation being done somewhere, and it's not on my computer. So this is done on the server. And this is what's called a server-side template injection. And fun part with server-side template injection is that can lead to remote code execution. That's perfect for us as the hackers, but not so good for the other side. So the first thing that we need to do is try to figure out what is the template that we're using in the backend. Because if we know that, we can create a good code to run, we can run our own code, more or less. So we know that we are in the bottom side here. We have tried the 7 times 7. So if we try the 7 times 7, but as a string, it should output 7 sevens. And the website does that, meaning that it's either Jinja or Twig in this case. And from our first reconnaissance, we saw that the server is running Python, and in Python, Jinja 2 is the default. So we're just going to assume this is Jinja 2. And nice things with template language in general is that they can store variables. And if we can inject code that is running as code in the server, we can print those variables to the screen. And config is the default variable for Flask applications, which usually contains your database, your passwords, your usernames, things like that. So if I just write config up in the URL, I can get the entire configuration of the server. So that's pretty nice. And you can see this website is run as a CTF. So if you want to run it sometimes, here's the first flag. So we've done our first reconnaissance phase. We know that we have a website, we have server-side template injection. We know that it can lead to a remote code execution. So now we need to weaponize it. And we need to take everything we know and make something to a weapon, more or less. So we need to write our own code to do something that we want the server to do instead. And to be able to do that, we need to understand a little bit how Python works. So in Python 2.3, they introduced the method resolution order. This means that every single class in Python is somewhat connected like a big tree. And with this, if you have a class in Python, you can actually print all the other classes in the Python code. It looks sort of like this, which means that you can traverse up your class into the next level of other classes and access them if we can use or can create a single class. And this is how you can do it. The brackets is a list in Python. A list is a class. We can do it the same with a string object. It's also a class in Python. So by just calling the class object, go to MRO, which is the method resolution order, go to the last part of it, the -1, and then just call the class subclasses. It will list every single subclass that the server or the program is currently having in its memory. And do we actually care about all the classes in Python? No. I mean, we're hackers. We only care about one single class in Python, more or less, which is the popen. Because with popen, we can run commands directly on the server. So we can open up a bash shell, for example, which is pretty neat. We can run everything that a logged in user on the server can run. So we actually have like shell access to it. So I just went to ChatGPT and said, I want to create a nice method that does a callback back to me. So this is a reverse shell. All it does is just, it connects back to my machine on port 4444. It opens up a bash shell for it. Great, so now we have our weapon. We need a way to deliver our weapon to the server. In our case, it's very, very simple. It's just put it in the URL and it will run. If we take a phishing attack, for example, then the email that the fish is coming to is the delivery method. While the weapon in that case could be like a link or a file or something like that. The exploitation step in this chain is just when the code runs on our victim. So we'll see how that looks like. So first thing we do, we just want to make sure that we have everything correct. And I like the website Payload All the Things. It's a GitHub repository with exploits, more or less. So I just go to that exploit or that GitHub page, search for server-side template injection. I know that the font is, you can't read it, but I'm looking for a Jinja to debug or dump all variables or dump all classes. And then I just grab that string that I found online. I go to our website. and then I run it. I just change the MRO to be the last one instead of number 2. And we can see all classes that we have in the web server. So I want to search for popen because that's the one that we are looking for, which is in the server or in the code. And funny thing here, I have not included this in my code. So even if you do a search on my entire code, you can't see the include of popen or subclasses anywhere. So this is a dependency from a library, from somewhere, I have no idea where it comes from, but it's there. And this is usually the case when it comes to these things. So then I just grab the next code from our website, which is I'm calling the OS command popen with ID. So I'm just running the ID on the server, and we can see that it actually prints the engines. So now we are running code on our server. So I'm just going to grab my weapon that I saw before. I'm going to open up a listener on my machine, and I'm going to run that instead of the ID command. I'm going to run my own code. Nothing gets outputted, but we have a shell. So in this case, I just got remote access to our server through the URL, which I think is pretty cool. The next step in this is that we need to have some kind of persistence, or an attacker at least want to be able to get back into the system even if you patch this. So they will install a rootkit on your server. We as penetration testers, we don't install rootkits because they are hard to get rid of, to be honest. So we usually install some kind of service that are just doing callbacks back to us all the time. So whenever we get access once to your system, we can get back into it again, even if you patch this during the penetration test. The next step is lateral movement. So we got into our server with the Nginx user. And to be honest, the Nginx user is a pretty boring user. It doesn't have any rights to do anything fun. So we would like to escalate this to another user. And there's a couple of ways of doing that. We will see how it works. So we will do a small reconnaissance step here just to see what we are allowed to do with Nginx, and then we will try to escalate that. So I'm logged into the server here. If I run who am I, I'm the Nginx user still. So the first thing I want to do is I want to open up a real shell, because shells that we are getting from a web server in this case are not the most stable ones. So the first thing that I want to do is I want to create a new shell. So I'm going to spawn a shell with Python. Just open up bin bash, and it will open a new shell for me, like that. And then I'm just going to do some background of the service, run sssty raw echo foreground, just so that I have tab complete, more or less, which makes everything a lot easier to work with. And then I'm going to run the sudo -l command. And what that does, it lists everything that my current user are allowed to run as sudo. And we can see that the Nginx user, for some reason, are allowed to run the tar command. I don't know if there's a exploit for tar, so I just go to GTFO bins website, and then I go here, then I just search for my program, which is tar, and I just grab this code. And hopefully, if I run this on the server, it will escalate my privileges to root. So now I'm root on the box. So I mean, with the websites that I've shown you, I mean, it's not really that hard to be a hacker. You can just go to those websites, and there are a lot of like predefined escalation points that you can just use under the right circumstances. So now we are root on the box. So we get our hands on the objectives if that was the case. When we're doing larger penetration tests, or if we were a proper hacker, we wouldn't stop here. So what we do when we have root on the box, we actually start over again. So now we start with the reconnaissance again, but as the root user on the server. Because now we might be able to get into your internal networks from here, or your demilitarized zone. And then we can do the same thing on the next server, and then the next server, and then we just tunnel through everything until we get to your Active Directory, or whatever our main target is here. Okay, so if we're gonna summarize a little bit on how we should think as a hacker, the first thing is just be curious. Make sure that you try to understand how everything works. Or, yeah, what do you think is fun, more or less? Poke at everything. I mean, hackers and penetration testers and QA testers, and they will try stuff that you're not supposed to try. If it says that enter a integer here, they will try everything that is not an integer. So if there's a button that says do not push, we will push that button to see what it does. If it's a door that says do not open, I will go into that door and see what's behind it. It's just, I don't know, a curiosity mindset that's how an attacker thinks. They are trying to get into places that they're not supposed to be in. Most tools that we are using and hackers, they are free and they are pretty easily accessible. So you can just download them and try them for yourself. And this is mostly what what we do. We're just Googling problems. And usually there's a Stack Overflow page that says, well, here's your fix for it. Oh, great. And then you try to figure out, okay, how do I break this fix? And there's a lot of proof of concepts for both CVs that you can just download and run, and it will work. So it's pretty easy to be like the script kiddie hacker, just Googling your problem, running codes that you find online, and yeah. So what we want to do, if we step away from the hacker point of view here and we try to look at it from a defensive side, what we want to do is that we want to make sure that we break this chain somewhere in the chain, because that's how we stop the attack from happening. The main concern from a developer is the exploit step, because that's when they are trying to run code in your code, so to say. But there's always a however. To be able to perform reconnaissance, you need to be able to gather information. So if you lock down your server as much as possible, so it's not leaking any information about what is running, versions, headers, anything like that, it's always harder to do the exploitation step. And even if your code is not vulnerable, it might be used to deliver vulnerable, or it might be used to deliver our payload to a vulnerable systems. So we can use your program as like a middle step to get into our real target. So if I have a database, for example, that is vulnerable, and you have a web pages running in front of it, we can use the web page to send commands to the database. And I've heard this a lot, but my code it's not accessible on internet. It's just an internal system. Yeah, but what happens when the attacker breaks your first layer of defense? So even if it's just a system that's running internally in your network, it can still be attacked if someone gets through the first door. And it can be as simple as when we're doing red teaming exercises, when we are getting into office buildings and just plug in a Raspberry Pi in the first outlet that we see. And then you have a DHCP server that just gives you an IP address, and then you can access your internal server. So even if it's not publicly accessible, it still needs to be patched and maintained. Yep, perfect. Okay, so how would we stop this hacker? So the first thing, we should always use static templates. In this example, I was using the input from the user and just put it directly into the template, generating the template on the server and then return it. What we should do is use a static template and only use the input from a user as like real strings in this case. So never run anything from the user. Send it as all inputs, everywhere, all the time. Yeah. I usually say that use some kind of coding standards when you code. It doesn't help you with fixing vulnerabilities per se, but it can help you actually finding vulnerabilities and make sure that your code is more easily readable if someone else is trying to fix your code in 5 to 10 years. Test your code. If everyone tested their code properly, I wouldn't have a job. But that's not the case, because every company is usually they want to get their code and their product out in the market as soon as possible. That's how it is. I mean, if you can't sell your product, then you're not getting any money. So there's always that we need to be fast and we need to be secure enough to be able to sell it. So make sure that you're testing your code and working together, both testers and developers, to make sure that your code is as good as possible. Then use low privilege accounts as much as possible. They did this in this case, so they were running the web server as the Nginx user. The problem is that they had some legacy stuff, which meant that our users were able to run certain commands as root. Make sure that you separate that, so you have specific tasks for specific users. And I always throw in OWASP. OWASP is a great tool if you haven't heard of it. It's an organization that puts up good baseline security standards and tests and things like that. So if you're not doing any testing or any standard or something like that, check out OWASP. It can help you at least get started. It won't solve all your problems, but it's better than nothing. Yeah, and I think that's a wrap up for it. Do you have any questions regarding anything? um, yeah. So the question were if our clients are run. Okay, where I found it. So the question is where we usually find these kinds of vulnerabilities, more or less, and it can happen anywhere. I would say it's harder to exploit like the privilege escalation point if you're running like a headless server somewhere, because usually you get blocked by the cloud provider in that case. So, but I mean, you can always find something. It's just how you do it. When we have a lot of customers that are running cloud or their workload in clouds, we are usually not attacking the infrastructure or the code itself. We are attacking the users, because if you can get into a user account, then you have complete control of their entire environment and not just that single function. So it's in that case we're just changing our attack path. But yeah, I mean there are there are vulnerabilities everywhere. Some parts are harder to get to than others. But I wouldn't say that there's a difference between if you run like a cloud machine, like an EC2 instance, or if you run it on-prem. That's more or less the same. Yeah. Any more questions? I can't see anything. Yeah. Yeah. So usually we as penetration testers, we are not working directly with developers per se. So usually we are doing a penetration test, we are writing a report, and we are in discussion with the security officer. And sometimes we are talking with like the CEO for the company, just bring the report and see, well, this is the issues that you have. But I mean, it's always, I should say, we don't want to go into a company and say that, well, everything that you have done is not good. We want to make sure that we are helping the developers and the testers and everything like that. Our job is just the last quality assurance. It's not something that we are going into a company and trying to break stuff for fun and then make fun of the client. I mean, our job is to help you guys. So we want to be like a part of your development team or your test team. It's just that we are the last defense before you go into production. But I mean, it's always hard to tell a developer that, oh, we found this major bug in your system, which means that we gain control of the entire infrastructure. It's not an easy conversation, and you need to make sure that you're doing it delicately. We actually found during penetration testers that we found the head of security's password when we did penetration tests. We could log in with his account, and he had access to everything. That was fun. It was a nice call to the one that actually ordered us to do a penetration testing on the system. But hey, you should perhaps change your password. Yep. 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 I do. And that is another type of penetration test, because when you're calling someone or when you do like physical penetration testing, you're not attacking a system, you're more attacking like the human mind. You're trying to trick someone to give you more information without them realizing that you're giving more information. So a tip, if you want to get into a place in Sweden, anywhere, just bring a large box and then have some like working pants with a hammer, and then you just wait for someone to open the door, and then you go in. No one will ask a question, I promise you. You can get in anywhere. Any more questions? Well, thank you in that case.